All right, friends and neighbors, I think we will try to wrap up all of this discussion on DNS with a three-part series on the resolvers and the name servers themselves. We'll also talk some about the protocol. So we know that the name servers are the repository for the database that has all of our zone information. So once we delegate authority to a name server, it is the boss for that particular domain. But central to all of this is the need to answer the queries, right? So the queries are generated by the resolvers, and the name servers are going to provide the answers to those queries. So the thing that requires all of the name servers and all of the resource records and the domain name tree that we've been talking about is the set of queries that'll come from a host. Now the queries themselves are generated in a particular name for it. And the thing that I want to remember here is that when we were looking at a zone file and we saw that we were doing, a name and then a class and then a type and then the resource record data or the R data, that entire line is what we're interested in. So we're going to format a query of that particular type and we're going to get an answer back of that particular type. So that's the thing that's really important to remember. So the query will generate a question, and then the name server will come up with an answer based on what it knows from its files, what it looks up in its own database, or maybe what it is cached from an answer that is seen before, or maybe we'll have to get an answer from someplace else. So that's really, really important. Okay, so the query has the opcode that tells us what's going on in a particular message. And all of these messages have a very similar sort of format, again, because we have the question that we're asking, the class, the type, and then the R data. Now, as we saw when we were editing resolve.config, the resolver, or the client side of this conversation. Now remember that a server can also be a client. In fact, most servers are clients. But a regular host that's a client is really utilizing what we call the resolver. And the resolver really has to start off with knowledge of at least one name server. This ought to make sense, right? How do you get anything done if you don't know where a name server is? Now we edited resolve.config to give not only the name server, but maybe the search string, right? So if I give a host just a host name, client1, and so instead of saying client1.bruce.com, it's just client1. Well, okay, so we gave it a host name, but it doesn't know a couple of things. It doesn't know what domain it's part of, so it has no idea where to start searching. So a lot of times we talk about a search string or a domain, and so that search string or the domain will be bruce.com in the example that we did with the DNS build. Now, also important to that is the name of at least one name server. And so whether you get that from DHCP or whether you manually put it in a file somewhere, it doesn't really matter, but you need to know at least one name server. Now, sometimes we put a secondary in there because the primary might not answer up, or the primary might be busy. We might get a timeout of some kind. So a lot of times we know about more than one server. But really, it's all about knowing at least one name server, and if not understanding the fully qualified domain name, then having a search string. So as I said, the DNS client is really the resolver. So we could get rid of the word client from here on out and say, oh, we're talking about our resolver. And so the resolver is going to generate a query that will result in an answer from the server. So we have to know the IP address of at least one name server. But the search string, to provide a little more detail on it, right? If I have a client that's in not just a secondary level domain, but also maybe one of the subdomains. So at RIT, it might be IT or CS or gccis.rit.edu, and then we might have subdomains further down in there as the example shown here on the screen. And so the search string might begin, when you start with a name, it might begin with fred.syslab.it.rit.edu. That doesn't exist. We'll work our way up the chain until we finally find it. Okay, so this slide just sort of shows what a standard query looks like. And so what we're interested in here is that, one, who is this coming from and where is it going? So we're going to a particular server. So this one starts with a client going to a particular DNS or name server, and then of course we're using port 53 for the request. This one is the beginning of the conversation. So it has a question but no answers. And so that's really, really important. And we can see that the query itself is a name, it's an address type with a class of internet. So if you read that from the resource record, it would be, what name are you looking for? What's the class, IN? And then what's the type, A? So what are we after in this particular case? We're after an address. We want an IP address. So those things that are included here in the query that you can see on the screen, that's the resource record information that we want. So this is the way that the client says, look, I need an answer, and this is the particular kind of answer that I'm looking for. So this is the query type that we're after. And so as we know from the RFC, there are actually a lot of different kinds of types that we can query, with one of the major ones being the address record. So let's put a couple of these ideas together, right? We know that a name server has this information stored in its files. Okay, but let's be really clear about something. When a name server is the boss, right? When it has the files themselves, it is authoritative for that particular zone. And so the essential task of a name server is to answer queries with the information that's in that set of files. Now, it's not always the case that the name server knows that, but the first stopping spot for the answer is for a name server to say, do I know the answer? And so if it's in the files, then it does, and it uses that information to provide the answer, and that becomes what we call an authoritative answer. Now, it's possible that a name server can be authoritative for more than one zone. It can also be a secondary and be given the latest and greatest information. So another big part of the process or understanding of the tree is that a name server is authoritative for only a part of the tree. Now, a name server might store information that it's learned from something else, but sometimes a name server will give you back a non-authoritative answer. And so it's important when you query a name server that the name server, upon giving you an answer, also provides an indication as to whether or not it's an authoritative answer. All right, so just to put a finer point on the zone data, we know that the data is contained within the files. Or, if you've got a GUI and you built that, right, it's stored on the server in the same or similar format. And the idea is that the zone files or the zone data is the authoritative information for that domain. Now, it's really important also that we understand, where a server or where a domain sits in the hierarchy, right? If you're not the secondary level domain, right, where do you live, and are there subdomains below that? All of the information is contained in the zone files, and it's not just what a server might be authoritative for, but also is there a delegation or is there a transfer of authority to a particular zone to make it authoritative? And so that's a really important idea too. The zone that we built in the demo build has no knowledge of the upstream or the downstream because it's not connected to anything. We did no delegation of authority. We didn't connect it. We didn't register it anywhere, right? So it has no knowledge of what's above it and no knowledge of what's below it. So any query that came in couldn't possibly be answered from that name server, except for things in that particular zone. Now, another way to refer to this is a portion of the tree or a cut in the tree. And so name servers are only authoritative for what we sometimes call a cut or a subtree of the entire system. Now, we know that when we build a zone file, there's a whole bunch of timers in there. One of them is that serial number. Now, the serial number is used to provide an indication of when this file was last updated, when the zone data was last changed, modified, things of that sort. And another timer says, listen, you ought to come back and check with the authoritative or primary name server on a regular basis, just to see if things have changed. Now, the minute we have primary and secondary name servers, or we have a conversation with upstream and downstream name servers, we want to make sure that we have the latest and greatest information. And so we transfer that information between servers based on that serial number and the retry. The mechanism that we use for this is something called the zone transfer. And it sounds really big and really awesome, but it's really just a conversation between the name servers to make sure that the zone files that they have are updated. But it is an important part of DNS. And so it has a special type of record, and the information that's contained in the start of authority record is where we get all of those timers. And this is just a little more detail, or a slide that sort of enumerates all of these things. And we have to remember that a name server can be primary for one zone and a backup or secondary for another zone. And so zone transfers can move both ways. And again, those timers describe how the servers interact and at what rate. And lastly, of course, the timers give us an indication of how good the R data from the resource records or the queries that we made, how good is that data? And at what point do we say, well, listen, the primary is not answering up anymore. Maybe it's time to age out those records and then go to a secondary. Another important aspect to name servers is whether or not they're caching name servers. The idea here is that, one, a name server is authoritative, and it sounds like, oh, big man on campus, right? But it's only authoritative for that cut in the tree, a very small portion of the entire name or domain name tree. And so there are a couple of things that we can do to sort of optimize things. And one is caching queries or answers to queries that a name server has already seen or already been a part of. So when you query a name server, the name server comes back and tells you whether or not it was an authoritative answer and whether or not it was non-authoritative. And it can even provide the name server for the information. Now, if a name server comes back with an answer that it had stored because it saw something previously, that's a non-authoritative answer. And as we know now, all of these resource records have a timer associated with them. So how long do I hang on to this before I say, it's kind of aged out? Now again, the optimization thing is, do I go with long or short time periods? If I go with short time periods, I know that my data is always up to date, but that also means that I have a lot more messaging in between clients or resolvers and the servers, or even in between servers. So that may or may not be a problem, right? We usually try to pick a time that keeps the data reasonably refreshed, but it doesn't overrun our servers. So if you have things that don't change very often, then you can go with long time periods. Now, of course, the opposite is also true, right? If you go with these really long time periods, the servers are much less busy. However, you might be stuck with information that is aged out. And here is a diagram right from the RFC. And so we can see that we've got the user program over here, and this is, whatever reason you have for making a name server request or a query. So were you looking for a web page? Were you doing a ping based on name, FTP, gaming, whatever it was? The application says, I need to know this information, sends it to your resolver, and the resolver goes to the name server. And of course, the name server comes up with an answer, either from its authoritative information that it has in its own files or some cached information, but that's the shared database that we're referring to. And anytime you're dealing with a foreign name server, we're just saying, well, listen, I have to do different kinds of queries sometimes, and sometimes I need to talk to somebody that's not my direct name server. And your name server can be queried by folks outside of your organization too, or from various parts of the web, especially if they're public. And this sort of underscores one of the things that we've been talking about up to this point, the delegation. So if I create a subdomain, gccis.rit.edu, if rit.edu doesn't know about gccis, well then it can't possibly refer queries down to that name server. And it'll constantly come up with errors or timeouts or no answer found to the queries that come in for any of those names associated with that subdomain. And so the delegation means that the upper level name server knows about this downstream authoritative server and vice versa. So that's a really important part of the process. And so we remember that when a query comes in, a name server can say, hey, that's not me. I know an authoritative guy downstream. Or I can say, well, I've got this query. I don't have it in my authoritative zone files, and I haven't got a cached entry to it, but I know somebody who might know the answer, and we pass it back up the tree. And so that's kind of how this whole thing goes together. Well, that'll do it for name servers and resolvers and the protocol part 1. There's still lots more to the story, right? We can't cover everything that's in DNS in a series of videos, but hopefully it's helping. In this video, we talked about primary and secondary. We talked a little bit about caching and non-caching, authoritative versus non-authoritative lookups. Let's take a quick look at an actual lookup. So we'll start with these basic queries here. So these are queries that I just made of the same name server that we did in the build from the previous video. And in the first, we have a forward lookup, ns1.bruce.com, and then we've got client1.bruce.com. And then there's a reverse lookup, 172.16.02 right here. And we can see that that came back with the name instead of the IP address. And then right here is a CNAME lookup. So if we take a quick look at the conversations associated with those lookups, we'll understand a little bit more about the protocol. So right here is the first lookup that we do. And we come over to the query, and we can see, first of all, 172.16.02 is the client, 172.16.01 is the server. So if we remember that for these conversations, and we can see that there's one question. So it's a very, very particular format. We have a transaction ID, we have a set of flags that indicate what kind of query is going on here, and then here is the actual query itself. And we can see that I'm looking for this name. We got that from the NS lookup page. We see we've got a class that's IN. Of course, most of the time today you're going to run into a class that's IN. So it's not unusual to see that. But this tells us that we're looking for an address, an A record. And so this is saying, I want the address that goes with ns1.bruce.com. Now Wireshark is handy, right? It shows us which ones go together, but we could also look at the transaction ID. So if I look at the transaction ID, D176, there we have it. And so if I collapse this for a sec, I've got a query and answers, but this tells me right here, I've got the first question that I asked, the answer, and then whether or not it was authoritative. So here was the query, right? Let's take a look at the answer. Well, here is the question that you asked. And again, type A, class IN, here's the address that goes along with the thing that you were looking for. And oh, by the way, here's how long you ought to hang on to this information. And by the way, here's the authoritative name server that this came from. Okay. So the next query was, let's see, we'll go down to, here was the next query that I did. Again, a question, query, address type, and then again showing us which ones go together. And we'll close the query, and there's the answer that comes back. Now, by the way, I'll point out a couple things here. We've got, if your name server was allowing IP version 6 queries or things like that, you can also have more than one response to a particular query when you're trying to get all the information with regard to a client. So that's why we see lots and lots of messaging here. But let's take a look at, again, we're looking for queries that come from the client. And here we've got another query from the client, and this one is that reverse lookup. So again, the class is the same, but hey, here is the address that I'm looking for, but I want the name this time. So this is a PTR query, a pointer. Who is this? And so the server comes back and says, by the way, here's the original question that you asked, and here is the client that goes along with that. And so this is really an important part of this, right? So that's the forward and reverse lookups that we did for that. And then here is the canonical name lookup. So, but the resolver doesn't know that it's a canonical name lookup. What the resolver says is, I want the address that goes along with this. So the server gets this. And now the server is going to try and look at its zone files and find the address that goes along with this. But what we find out is the server says, well, Let me fix my window here a little bit. So here was the query, right? So we'll close this. And the server comes back and says, oh, by the way, yeah, that was not an actual name that I have. I don't have, Dr. H. .bruce.com. What I have is a CNAME record for that. So what you really wanted was this here. And so that's what it comes back with. That's the information that the server looks up in its database and says, well, this is the real answer that you want. But we can see in our format, right, everything is exactly the same. We have the questions and the answers are formatted in the exact same fashion. Now, the extra information that's here, there's a lot more detail, obviously, to a query that goes on, and to the protocol. We'll talk more about that in another video. But there you have it. There is the basic header format, the questions, and then we can see that in the case of a CNAME, sometimes we get more than just one answer because there is no proper resolution or no direct resolution for an address record for a CNAME. So next up, we'll talk about resolvers and the actual resolution and maybe the protocol in subsequent videos. Okay, thanks for watching. Like and subscribe if I helped. And may your resolver queries always reach that authoritative name server.